Now we are going to discuss the questions that involve exponential and ln functions. Look at example 1. Given fx and gx, we need to find gfx and fgx. First, to find gfx, we need to substitute f function into g function. To find fgx, we need to substitute g function into f function. B. By using graphical method, determine the domain and range for gfx and fgx. So gfx is given by e to x plus 1. So by looking at the function, we have a positive e and a positive x. So this is our basic shape. Then we know that we have a horizontal asymptote at x equal to 0. So to find the intersect, at x equal to 0, gfx will be equal to e. Our domain will be negative infinity to infinity and our range will be 0 to infinity. For fgx, we have 2ex plus 1. The basic shape of the graph is this one. So we know that our horizontal asymptote will be y equals to positive 1. To find the intersection, substitute x equals to 0. And we have the domain and range. Example 2. We have fx and gx. We need to find fg inverse x and g inverse fx. So first, we have to find what is g inverse. We use g inverse x equals to x. Then, we get our g inverse. To find fg inverse x, we substitute g inverse into f function. To find g inverse fx, we substitute fx into g inverse. B. We need to sketch the fg inverse x and g inverse fx function. And we need to state the domain and range of both functions. So our fg inverse x function is equal to ln x minus 7 divided by 2. To sketch the graph, we need to find the domain first. fg inverse x exists when x minus 7 over 2 is greater than 0. We bring 2 to the right hand side. So we have x minus 7 greater than 0. So x is greater than 7. Now we know that our function exists when x greater than 7. So we have our domain to be 7 to infinity. We know that our function exists at x greater than 7. So it means that we will have a vertical asymptote at x equal to 7. By looking at the function, we have a positive ln and a positive x here. This is the basic shape for ln x. Therefore, our graph will be like this. At fg inverse x equal to 0, so 0 is equal to ln x minus 7 over 2 x will be equal to 9. So this is 9. And of course, our range will be negative infinity to infinity. Next, g inverse fx is given by 1 over 2 ln x minus 2 minus 3 over 2. This function exists when x minus 2 is greater than 0. X must be greater than 2. Our domain for G inverse fx is equal to 2 to infinity. And of course, the range will be negative infinity to infinity. To sketch the graph, we know that our graph will exist at x greater than 2. So at x equal to 2, there will be a vertical asymptote. By looking at the graph, we have a positive ln and a positive x. So our basic shape of the graph will look like this. So this is our graph. To get the X intercept, at G inverse fx equal to 0, 0 is equal to 1 over 2 ln x minus 2 minus 3 over 2. 3 over 2 is equal to 1 over 2 ln x minus 2. Multiply to both sides of the equation, so you have 3 is equal to ln x minus 2. E3 is equal to x minus 2, so x will be equal to E3 plus 2. So this is E3 plus 2. Example 3. Given fx equals to ln x, we need to find the f inverse and sketch the graph of fx and f inverse x on the same axis. So to find f inverse, f inverse x is equal to x. We need to substitute f inverse into f function. So we have ln f inverse x is equal to x. As ln is equal to log base e, by using anti-log, we will end up with f inverse x is equal to ex. So we need to sketch fx and f inverse on the same axis. Now you have two options. You can choose either to sketch ln x graph, or you can choose to sketch ex graph. It's up to you. Which graph do you prefer? So I'm going to sketch the ex graph. This is the graph for ex. As x equal to 0, this intercept will be equal to 1. To get the other graph, you just need to reflect your graph at y equal to x. So this will be your graph for fx. If you have y-intercept at 1 for f inverse, then it will be x-intercept at fx. Example 4. Given fx equal to e to x minus 1, first we need to find the f inverse. Next, we need to determine the domain and range for f inverse. And we need to sketch the graph of f and f inverse on the same plane or on the same axis. To find f inverse, we use f inverse x is equal to x. We need to substitute f inverse into f function. So we have e2 f inverse x minus 1 is equal to x. So e to f inverse x is equal to x plus 1. So we put ln at both sides of the equation. By using properties of logarithm, we have here 2f inverse x is equal to ln x plus 1. Therefore, f inverse x is equal to 1 over 2 ln x plus 1. To determine the domain and range for f inverse x, we look at the f inverse x function. F inverse x will exist if x plus 1 is greater than 0. So x must be greater than -1. So our domain for f inverse x will be -1 to infinity, and range for any lone function is -infinity to infinity. Now we need to sketch the graph of f and f inverse x on the same plane. So it's up to you, either you want to choose the exponential function or the natural log function. Say that I wanted to choose the exponential function. I know that there will be a horizontal asymptote at y equal to -1. So there will be a -1 here. We notice that this is a positive exponent and a positive x. So the basic shape will look like this, EX. We need to find the intersection at y-axis. So at x equal to 0, fx will be equal to e2 times 0 minus 1. E0 minus 1 minus 1 is equal to 0. So our graph will intersect at 0, 0. So basically this is our graph. This is fx. To get the other graph, we need to reflect the graph at y equal to x. Before you reflect the graph, you need to reflect all the points on the graph first. So here we have a horizontal asymptote at y equal to -1. So if you want to reflect the graph, there will be a vertical asymptote at x equal to -1. So our graph will look like this. This is f inverse x. So if I ask you what is the domain and range for the f function, you basically can get the answer from the graph or from the domain and range for f inverse. This is equal to the range for fx, and this is equal to the domain for fx. Example 5. Given fx equal to ln 3x plus 2, we need to find the f inverse and sketch the graph of fx and f inverse x on the same axis. To find f inverse, we use f inverse x is equal to x. We substitute f inverse into f function. As ln is equal to log base e, by using the anti-log, we have 3f inverse x plus 2 is equal to ex. Therefore, f inverse x is equal to ex minus 2 divided by 3. Or we can write it as ex over 3 minus 2 over 3. You can choose either to sketch the graph of natural log function or exponential function. So in this question, I chose to sketch the ln function. Fx exists when 3x plus 2 is greater than 0. So x must be greater than -2 over 3. Because of that, I know that there will be a vertical asymptote at x equals to -2 over 3. By looking at the function, this is basically a positive ln and a positive x. So the basic shape of the graph will look like this, ln x. Now we need to find the x intercept. At fx equal to 0, 0 is equal to ln 3x plus 2. E0 is equal to 3x plus 2. 1 is equal to 3x plus 2. So 3x is equal to negative 1. X is equal to negative 1 over 3. So this is negative 1 over 3. So basically this is your graph. To get the y-intercept at x equal to 0, fx will be equal to ln 3 times 0 plus 2. So you have here ln 2. This is ln 2. To get the other graph, you need to reflect your graph at y equal to x. Before that, you have to transfer all the points that you have on the graph. If you have a vertical asymptote at x equals to negative 2 over 3, when you reflect the graph, it will be a horizontal asymptote at y equals to negative 2 over 3. Ln 2 at y-axis will be ln 2 at x-axis. Negative 1 over 3 at x-axis will be negative 1 over 3 at y-axis. Therefore, your graph will look like this. And this is f inverse x.